Now, let us look into an example to cater for what we had about the simple gear train. We are given here that the input shaft and pinion of a simple gear train have a combined moment of inertia of 2 kilogram square meters. So what we are dealing with, one, it is a simple gear train. So remember what I had before, guys, that if you are dealing the simple gear train, you're gonna have two gears, A and B, one connected to the input shaft. So a simple gear train, each gear on each shaft, each gear on each shaft. So B has got its is connected to its shaft on the output, which is number 2, and A is connected to what? To the input, which is 1. So A being the driver, B being the driven. So A, that is the pinion, the driver. So they are saying everything combined here, the input shaft and the pinion, the input shaft and pinion combined together. You work with that shaft connected to gear A, which is our pinion. The combined moment of inertia is what? 2 kilo. Everything there combined. So we are given I1 there. For a simple gear train, that is I1. All right. So we are given this as 2 kilogram meter squared. And also, we are given that, and the output shaft and the driven gear have a combined moment together there. The driven gear B and output, everything. The moment of inertia is given as what? 4 kilogram square meters. All right. So that's I2 on the output. 4 kilogram square meters, as well as their corresponding speeds. The speed of the input shaft 1, and the speed of the output shaft, which is 2, is 300. So we are given the speeds corresponding to the input shaft 1200 revs per minute, corresponding to the output shaft 300 revs per minute. So from there, you are now asked, calculate the following. Number 1, the equivalent moment of what? Inertia referred to the input shaft. Referred to the input shaft on a simple gear train, and given, we are not even given efficiency there. So we assume 100%. So these are the formulas that you're going to use. All right. If you wanted, you can use those ones that you've got efficiency, but you put 1 where there is efficiency. When it is like this, assume at 100% or efficiency. All right. We're not given efficiency. So meaning to say, as we are referring to the primary, to the input, this is the formula that you're going to need. All right, 800% efficiency, no effect. Just take your formula as it is. So remember our formula, IE1 is equal to I1 plus I2 into what? N2 over N1, referred to the primary, remember, squared. So this is it. Are we having this? Yes, we've got everything. Everything is there. So just substitute into the formula, you are done. So IE1 was going to be I1, which is 1200 plus I2. Guys, what am I doing? What am I doing here? I1, that's 2. Then I2 is what? Is 4. All right, so that's into N2 over N1. The speed N2 is 300. over N1 1200 raised to the exponent of what? Of 2. So that's it. You are just going to use your calculator, and that was going to give us something like 2.25 kilogram meter squared. Please use your calculator properly. So as we can see, it was a direct question, nothing to be adjusted. Then the equivalent moment of inertia referred to the output shaft again. This one is a direct formula, as we had this one before at 100% efficiency. So that's our IE2. Oh, let me just put it here, guys, where we have got our information. Remember, we calculated equivalent referred to the input, and that was 2.25. All right, let us move on. When referred to the output, that's IE2. So IE2 from our formula, it's going to be I2 plus I1. Then the speed 2, so it's going to be N1 over N2 in the denominator. All right, so again, this one is direct. We've got everything. Just substitute. I2 is 4. I1 is 2 over what? N1, 1200 over what? Over 300 to the exponent of what? Of 2. So that was it. And with your calculator, you're going to have this value of 36. So we have got 36 kilogram square meters as our equivalent moment of inertia referred to the what? To the output. All right, so that is it. That is it. In case we're gonna need this, then we have to use the value that we calculated. All right, so that was the question. Let us move on to number 3. Number 3 is the input torque required if the input shaft is accelerated at what? All right, they removed one another part of the information is 2. It was supposed to be accelerated at 2 rad per square second. That was what we had there. All right, I don't know what just happened, but that is the input torque that you're going to have on number 3. All right, if the input shaft, we are dealing with what? Input shaft is accelerated at the input. So it means this angular acceleration is for the input. So we're given angular acceleration for the input at 2 rad per square second. We need to calculate the input torque. So you can write T1 or Tn, it's in your hands. Remember, I talked about this to say if we have the torque is simply moment of inertia times what? Angular acceleration. So you use the equivalent now. All right, you still remember here when I explained this input torque, it can be output depending on the question. So here they want input. So you must have equivalent, of which we calculated that one for the input. The equivalent is there. So this one was also a direct question. We need equivalent. Some other textbooks, they write this one as IT, total moment of inertia. But as long you know that it is referred to the what? Input. There is the total for that input. This is the total for the what? Output. It is also applicable. Angular acceleration must be for the input as we refer to the input. For the output must be for the output. So that is it. We have got everything here. So let us just substitute. Equivalent moment of inertia was given. We calculated this as 2.25. Then the angular acceleration being 2 as we are given. So multiply this, we're going to get 4.5. So this is torque measured in what? In Newton meters, just like that. So you see, guys, it is just a direct application of what? Of formulas. All right, so we shall see in the next classes how questions can be given. Just use this information now to attempt questions based on what? Based on a simple gear train. you can answer any question with this information and what we had before. Adding these other formulas that we had, you can answer any question. So that is it till we meet again.